Okay, we are going to work on page 37a. We're going to go over transformations of linear functions. So I want you to open up to page 37a. You are going to be looking at this page, but I am going to be showing the work on a different page. Okay, so first we need to go over what the parent function is. A parent function is the most basic function for that type. So far, the only function we've been working with is a linear equation. So the parent linear function is this, f of x equals x, which is the same as y equals 1x plus 0. So the parent linear function has a slope of 1 over 1 and a y-intercept of 0. So that's considered the most basic parent linear function. Now, we are going to graph a group of different functions, but we're going to always be comparing it back to the parent linear function. So what I want you to do on page 37a is you are going to graph the parent linear function 4 times. And I'm going to show you how to do this quickly. Now, I'm going to do the first one slowly, but then I'm going to show you for the second ones how to do it. So we start out where the y-intercept is 0. We go up 1 over 1, 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 up 1 over 1. And a quick way to do it, you notice it ends up at the top right-hand corner. So you can just put a point at the top right-hand corner, at the bottom left-hand corner, and in the middle, and just connect those 3 dots, and that's your parent linear function. Kind of looks like a 45-degree angle, because this is 90 degrees. It looks like a 45-degree angle. So I'm going to put my point there, and my point there, connect my dots, and that's the parent linear function. So we can label that f of x equals x, f of x equals x. Now, if you have a different colored pencil, we can graph the other comparison functions using a different color. So, for number 1 on page 37a, we see there's another function. I'm going to put it in green. G of x equals x plus 3. So to graph this, it also has a slope of 1, but it has a y-intercept of 3. So I start 1, 2, 3. I start with a y-intercept of 3. Then I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And I realize this line is parallel to the parent linear function. It is parallel, but it has shifted up 3. So when something shifts either up or down, we call that a translation. So this is a translation of the parent linear function. And we know it's a translation because we added or subtracted. And if you remember when we translated our shapes, we said a translation would be something like x plus 2, comma, y minus 3. That would be a translation. Same thing here. When you're just adding or subtracting and not changing the slope, it's translating. Now, let's look at number 2. Number 2, they give us another function, h of x equals x minus 4. So for this one, I start with a y-intercept of negative 4. And then I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And I notice this is also parallel to the parent linear function, but it's shifted down 4. So this is also a translation. Now, how did I know it was a translation? Because it's subtracting 4. And whenever we're adding or subtracting to our parent function, that's a translation. It will either be a translation up or a translation down, but the slope does not change. Okay, so that is how we do a translation of the parent linear function. Now, for the next two, see if you can look ahead and guess what type of transformation that is based upon what we did with the shapes before. So what did we call it when we multiplied by a number greater than 1 or multiplied by a number in between 0 and 1? So for number 3, again, I'm going to draw the parent function. Hopefully you've already drawn the parent function. Remember, I go from corner, middle, corner, like a 45-degree angle. I draw my parent linear function. Corner, 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 connect them, 45-degree angle, parent linear function. Now, for number 3, they have h of x equals 2x. So now notice the slope has changed. And the absolute value of my slope is greater than 1. And when the absolute value of the slope is greater than 1, we call this a vertical stretch. So instead of going up 1 over 1, I go up 1, 2 over 1. Up 1, 2 over 1. Up 1, 2 over 1. And this is a vertical stretch. Now notice every point on this blue line is further away from the x-axis than every point on the red line. Notice the red line is closer. It's because the blue line is stretching away from the x-axis, and that's what a vertical stretch does. Now, for number 4, it says h of x equals 1/2 x. And I wanted to do that in blue, so I'm just going to redo that. H of x equals 1/2 x. So now, instead of going up 1 over 1, I go up 1 over 2, up 1 over 2, up 1 over 2. And this is a vertical shrink. Now, with a vertical shrink, notice that every point on the blue line is closer to the x-axis than every point on the red line. That's what a shrink does. So when the absolute value of the slope is in between 0 and 1, this is called a vertical shrink. Okay, so to review, when the slope stays the same, but you add or subtract, that was a translation. When the slope is greater than 1, it's a stretch, absolute value. And when the absolute value is between 0 and 1, that's a shrink. Now, we're going to turn the page. So turn to page 37b. And we are going to do a reflection. So now look at number 5 and 6 on page 37b and see if you can guess what is making it reflect. And if we think back to when we reflected the shapes, what made things reflect was multiplying by -1. And here it's the same. So whenever you have a negative slope, it is called a reflection. So for a linear equation, a reflection means there's a negative slope. Okay, so first I'm going to do, again, the parent function. We do that 45-degree angle through the origin. And 45-degree angle through the origin. And now, this is just m of x equals -x. So when I graph this, instead of going up 1 over 1, I go up 1, left 1, up 1, left 1, up 1, left 1. And this is a 45-degree angle, but it's through quadrants 2 and 4. that is a reflection. And whenever you have a negative slope, it's a reflection. Now, for the next one, it's d of x equals negative 3x. So this has an absolute value of negative 3 equals 3. Remember, if the absolute value is greater than 1, it's a stretch. So this is actually going to be a vertical stretch with reflection. Okay. So instead of going up 1 over 1, I go up 1, 2, 3 to the left 1. 1, 2, 3 to the left 1. So this is going to look something like this, where it's stretching, but it's also reflecting. Now, if you look at those next two, you will see that most linear equations are a combination of stretches, shrinks, reflections, and translations. So let's look at number 7, and it is h of x equals 1/2 x plus 1. And number 8 is p of x equals negative 2x minus 1. Okay. So number 7, because this is 1/2, because the absolute value of the slope is in between 0 and 1, this is a vertical shrink. And because we're adding 1, we're translating up 1. So this is a vertical shrink and a translation. Now for number 8, because that's negative, this is a reflection. Because whenever the slope is negative, it's a reflection. Because the absolute value of negative 2 is greater than 1, this is a vertical stretch. Because whenever the absolute value of the slope is greater than 1, it stretches. And because we're subtracting 1, this is also a translation. So this last one is an example of 3 transformations happening. It's reflecting because it's a negative slope. It's stretching because the absolute value of the slope is greater than 1. And it's translating because basically whenever the y-intercept isn't 0, it's a translation. Okay, so now if you turn the page, if you turn to page 37c, and you look in the right-hand column, it basically sums up for you everything we just did. So you turn the page and you look at the right-hand column on page 37c. And you see that there's 4 types of translations. 4 types of transformations. Okay. Number 1 is a translation. And a translation has the same slope, but a different y-intercept. Examples would be y equals x plus 2, y equals x minus 3. Notice it's whenever you add or subtract, you translate. Second type of transformation is a reflection. And a reflection means you have a negative slope. So an example would be y equals negative x. Number 3, you can have a vertical stretch. And a vertical stretch is when the absolute value of m is greater than 1, such as y equals 2x, y equals 5x. And you can have a vertical shrink. And that's when your absolute value of your slope is in between 0 and 1. So y equals 1/2 x, y equals 1/5 x. Okay, so those are your 4 types of transformations. Now, remember that most linear equations would be a combination of these. So let's just go over a few equations and look at the type of transformations. So here, y equals 2x plus 3. So what types of transformations are occurring? Well, here, this would be a vertical stretch because the absolute value is greater than 1. And this would be a translation because you're adding 3. Let's look at another one. Y equals negative x minus 4. This would be a reflection. Why is it a reflection? It's a reflection because the slope is negative. This would be a translation because you're subtracting 4. And here's another one. Y equals 1/2 x plus 5. So what 2 types of transformations are occurring here? Well, this is making it a vertical shrink because the absolute value is between 0 and 1 of the slope. This is making it translate up 5, so that would be a vertical shrink and a translation. And that's the end of this video.